Hi, welcome. In this video, I will be talking about probability. I will be going over a few problems. The first problem here says an urn contains 12 blue balls and 8 yellow balls. We notice that an experiment will involve drawing a ball from the urn, which will lead to one possible outcome of a blue or yellow ball. The approach used here will be classical because each ball will have equal chances of getting selected. Now, suppose two balls are drawn randomly from this urn. What is the probability that they are both yellow? Let's assume this is done with replacement. To compute this probability, we want the probability of the first ball yellow and the second yellow. So this will be an example of independent events because each time a ball is drawn, it is put back. So the probability of the first one being yellow will be 8 over 20. The probability of the second one being yellow will be 8 over 20. So the probability of both being yellow will be the product of these two, which will be 0.16. What is the probability that the first is blue and the second is yellow? In this case, we are assuming the balls are drawn without replacement. In this case, the events will be considered to be dependent events. The probability the first is blue and the probability the second is yellow will be the probability the first is blue multiplied by the probability the second is yellow given the first is blue. So the probability the first is blue will be 12 out of 20. The first ball has been drawn without replacement. So the probability the second will be yellow will be 8 out of 19 because the number of balls in the urn would have reduced by 1. So when we take the product of these two, it gives 0.25. For the next problem, the majors of graduates and the number in each major within the business school is shown in the table below. What is the probability that a randomly selected graduate is an accounting major? If we look at this table, it is an example of a frequency distribution table. So in computing our probability, we're going to be using the empirical approach because now we are using information from historical data. So to compute the probability, we are going to be looking at how many are account majors, which in this case is 56, and then the total number of all graduates that we have, which is 200 in this case. So our probability in this case becomes 0.28. Next, we look at the question, what is the probability that a randomly selected Ontario resident will test positive for COVID-19? In this case, we are going to be using what we call the subjective approach. Now, this is just going to be based on an educated guess or based on observation. For example, we know that in some areas are considered to be hotspots and data is being recorded from time to time. So to be able to determine this, you have to use an educated guess and the approach will be considered to be subjective approach. Next, we look at the following question. Jane simulates the toss of a coin 1,000 times using a computer software. Approximately how many heads will come up? Now, in this question, we are going to be talking about the law of large numbers. Now, she has simulated the toss 1,000 times. So, what the law of large numbers is saying is that when we perform this experiment many times, the empirical probability will approach the classical probability. Now, the classical probability of getting heads when we toss a coin is 0.5 or 1 out of 2. So as a result of that, we'll expect that she will get approximately 500 heads in this case, using the law of large numbers. Next, we look at the following problem. A couple plan to have 3 children. Identify the sample space. What is the probability that they will have 2 girls and 1 boy in any order? We answered the second part of the question first. For 2 girls and 1 boy, we can see that is either they have a boy third, a boy first, or a boy second. So these are all of the possibilities. And each time the events are independent events. So for example, the probability they will have a girl and then a girl and then a boy will be 1 over 2 times 1 over 2 times 1 over 2, which is 1 over 8. And since they are independent events, each of this will be 1 out of 8, 1 out of 8, and 1 out of 8. So the probability that they will have 2 girls and 1 boy in any order will simply be 3 out of 8, which will be 0.375. Now looking at the sample space, we can list all of the possibilities. In this case, there will be 8 possibilities of the order in which they could have these 3 children. Now, every time they have a child, they have 1 of 2 options, boy or girl, and they want to go 3 times. So the total possibilities will be 2 raised to the power of 3, which will be 8. So if we wanted to list the sample space, it will be given right here. It's either they have 3 boys, 2 boys and a girl, a boy, a girl, and a boy and then 2 girls, a girl and then 2 boys, a girl, a boy, and a girl, 2 girls and then a boy, and lastly 3 girls. Now, the easy way for us to be able to list what we have in this sample space is to use the probability tree, which we can be able to see here. In the first trial, they will have either a boy or a girl. Then, if they had a boy the first time, they can have a boy or a girl the second time. And then if they had a girl the first time, they can then have a boy or a girl. And then we follow the branch. In the third, is either they have a boy, girl. If they had a girl second, they can also have a boy or a girl third. And if they had a boy second, they can have a boy or girl third. And then if they had a girl here, they can either have a boy or a girl. So to be able to list all we have in the sample space, we just need to follow the branches. We have boy, 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 girl, boy, girl, boy, boy, girl, girl, and then coming down here, girl, boy, boy, girl, boy, girl, 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 boy, and lastly, girl, girl, girl. So that's how we arrive at our sample space. For the next question, James is taking statistics and business math. The probability of passing statistics is 0.65 and the probability of passing business math is 0.75. The probability of passing both courses is 0.55. We're supposed to find the probability that James will pass statistics or business math. So here we're going to be using the addition rule. And then we notice that the events that it passes, statistics and business math, are not mutually exclusive since the intersection is not empty. So the probability that it passes statistics or business math will be the probability it passes statistics plus the probability it passes business math minus the probability it passes statistics and business math. And then we just put the values in from the question and we end up with the probability of 0.85. Next, the question says, what is the probability that James will not pass business math? In this case, we'll use the complement rule. The probability will not pass business math will be 1 minus the probability he passes business math. So which in this case is 1 minus 0.75, which is 0.25. The C part says, what is the probability that James will fail both courses? Again, we're going to use the complement rule in this case. The probability that it will fail both courses will be 1 minus the probability it passes statistics or business math. We already computed probability of passing statistics or business math in the A part of the question. So we just put that value in and then we get 0.15. Next, we'll take a problem involving a contingency table. Now, the contingency table will be using two characteristics, and then we can be able to find values within the cells. For example, in this question, it says, the following table divides up a group of 30 students by gender and employment status. Now, the table is given here, and this is an example of a contingency table. For example, in that cell, we can be able to see the number of females that are part-times, or in this cell, we can see the number of males that are full-times. Then we can be able to take the totals across the rows and down the columns, and we get a grand total of 30, which shows us how many students we have in this case. Now, the first question says, if a student is randomly selected, answer the question, what is the probability the student selected is female? In this case, we are going to see how many females we have by looking at the total across the row, which in this case is 24 out of the grand total of 30. So the probability in this case will be 0.8. We can also write that as a percentage, 80%. Then what is the probability the student selected works part-time? Again, we look in the table and find how many people work part-time. In this case, it's 15 out of 30, which will be 0.5 or 50%. The C part, what is the probability that the student is a male or works full-time? In this case, again, we are going to be applying the addition rule. That will be the probability they are male plus the probability they are full-time minus the probability they are male and full-time. The probability they are male will be the total of males we have, in this case, which is 6 out of 30. Probability of full-time will be the number of full-time we have, which is 7 out of the grand total of 30. And the probability they are male and full-time will be how many people are males and are full-time, which in this case is 3 out of 30. When we compute this, it comes to 10 out of 30, and we get 0.33 or 33%. Then what is the probability that the student is a female given he or she works full-time? Here we're going to be using the conditional probability. The probability they are female given they are full-time. So we have the probability of female and full-time divided by the probability of full-time. So the number that's female and full-time will be 4 out of the grand total of 30. And the number of full-time will be the total 7 out of 30. So the 30 will drop out, in the numerator and the denominator. And we have 4 out of 7, which is 0.57. Next, we'll go over some questions on counting principles. The first one here says, how many different ways can we arrange the letters of the word Kalamazoo? So now we're going to be using the permutation rule for the identical items. Now, if this will be the formula right here. Now, the total number of letters we have is 9. That's what we have on the top. And in the denominator, we are looking at the ones that repeat. A repeats 3 times, so we have 3 factorial. O repeats 2 times, then we have 2 factorial. So we can use Excel. If we go into any cell in Excel and type fact, it returns the factorial for that number. So when we compute this, we end up with 30,240 ways. The next question, a committee of 5 people were to be selected from a group of 12 people. How many different groups of 5 are possible? So in this case, we are going to be using combination, because anytime we select 5 people, it doesn't really matter what order, they are the same 5 people. My N in this case is 12 and my R is 5. Again, if I use Excel, I just need to go into any cell in Excel and type combine, and then N in the first position and R in the second position. And it returns for me 792 in this case. The next problem says Mary is on her way out. She has 3 bags, 4 shoes, and 5 dresses to choose from. How many different ways can she choose a bag, a shoe, and a dress? In this case, we are going to be using the multiplication rule. She has 3 ways of choosing a bag, 4 ways of choosing a shoe, 5 dresses to choose from. So when we take the product, we get 60. The next problem says a student needs to choose a combination for his locker. He can use the number 0 to 9 and repetition is allowed. How many different ways can he choose a 4-number code combination? Every time he chooses a digit, he has 10 options, 0 to 9, and he can repeat. So he wants 4. So that means that it would be 10 times 10 times 10 times 10. So this will be the total number of ways you can be able to choose a 4-number code combination. Next question says a committee consisting of 10 people needs to choose a president, secretary, and treasurer. How many ways can these choices be made? In this case, we're going to be using permutation because the order will matter in this case. The 3 people we are choosing, it would matter whether they are the president, secretary, or treasurer. So we're going to be using permutation. My N is 10 and my R is 3 in this case. Again, you can go into any cell in Excel and type permute, then your N, which is 10, and your R, which is 3. And this will return 720. Thank you for watching this video.